Good morning, everybody. I hope you're enjoying your coffee and listen to great talks today. I have the honor to start the second day of the Hacktivity 2020. My name is Moritz Abrell, and in the next couple of minutes, we will attack a modern unified communication infrastructure. Who am I? I'm an IT security consultant for a German company called SySS. I have been working with voice over IP and unified communication technologies for years with a special focus on IT security. And finally, I'm just another guy who is interested in information technology and IT security. When we hear about voice over IP, we usually see something like this. 2 IP hard phones and 1 IP PBX. And for signaling, they're using SIP, and for media transport, they're using RTP. But my opinion is this chart is no longer current. Let's look at a common voice over IP and unified communication scenario of a medium-sized company. Obviously, we have still PBX and desk phones. But we also have soft phones and some kind of unified communication client. And because the IT administrator loves to central administration, we also have some kind of application server. It also provides the backend for the unified communication software. And because the IT administrator do not want to maintain 2 user databases, we often have a LDAP connection to the Active Directory. All of these are only the internal services, and we have not talking about fax applications or contact center systems and so on. But today we usually have SIP trunks to call to external parties. And because of the corona crisis, we also have remote workers who want to communicate with their IP phones or their smartphones with the Office extension. Also important for communication and collaboration is a conferencing system where we can meet our colleagues from everywhere on the planet. But we want to keep our internal network secure and clean, so we implement a session border controller. It is a kind of voice application firewall. And finally, because we all hear these horror histories about man in the middle and eavesdropped calls, we separate our internal network to keep it secure. Okay, now we know the scenario. Let's talk about the agenda of this talk. Well, it's pretty simple. We will attack all these applications. But first, let's talk about the problems with the tools. There are not many tools for voice over IP security analysis, and those there are available, they partially outdated, too static, and sometimes manufacturer dependent. So based on this problem, I developed my own toolset, which is called WireBug. It is open source and it's written in Python. The advantages of this open source project is that it is manufacturer independent, customizable, and it comes with a wizard to keep the usage simple. Because everybody knows these long and complex terminal commands. But if you like these, you can use every tool independently from the command line. So, in order to get warm, we start with the network separation of the desk phones. Everyone knows network access control with 802.1x and MAC-based authentication. But this is not the point in this talk. If you're interested how to bypass this, you can read the linked document and use the open source tool of my colleague. For automatic voice over IP VLAN assignment, a protocol called Link Layer Discovery Protocol with the media extension is often used. It is a layer 2 based protocol with no authentication. And it's for exchanging information like VLAN IDs, server addresses, quality of service things between network neighbors. This protocol is pretty cool for automatic rollout, because you plug in a phone and the switchboard will be configured with the voice over IP VLAN, and the phone knows which VLAN ID it has to tag on its network interface. But because it has no authentication, an attacker can pretend to be a phone, and the switch will say, "Hello IP phone, please set the VLAN ID and I will give you network access to the voice over IP VLAN." So now it's time for a demo. So first I start WireBug with its built-in wizard. As you can see, WireBug supports also tab completion. We have to do LLDP spoof, enter the interface in the vendor, send the packet to our network neighbor, and we will receive a response. If we go into the LLDP response packet from the switch, we can see the VLAN ID 301. And if we now create a virtual interface with the tagged VLAN ID 301, we have access to the VoIP network. Okay, now we're in the VoIP VLAN, so let's look at the IP phones. Eavesdropping calls is not so easy today because we usually have encrypted SIP and RTP traffic. Encryption for SIP is done with usual TLS, but because RTP is a UDP-based protocol, RTP is encrypted with other methods, and desk phones almost all using SRTP STS method. In this method, the AES key for symmetric RTP encryption is delivered in a signaling part. And in SIP, it is a media attribute called crypto, which can be found in the body of SIP. So the problem is, if an attacker has access to the signaling stream, for example with a simple TLS proxy, he could decrypt the call. And yeah, the TLS proxy method usually works because certificate validation is a foreign word in ZIP. And in case the phone and the server validates the certificate correctly, sometimes you could find the signaling traffic in the log files which are publicly accessible on the web server of the phones. And additionally, this is not end-to-end encrypted. So it's time for the next demo. I have this network capture of a voice call, and if we analyze the stream in the capture, we will see random noise, which is an indicator for encrypted call. So yes, it is encrypted. So now let's have a look at the SIP packets. In the body of the SIP invite packet, we can see the crypto attribute with its key for RTP encryption. For further steps, we copy this key. And because we only want to decrypt the correct RTP stream, we have to extract only the RTP packets into a new file. Yeah, sometimes these GUIs are not so easy to handle. Okay, Now I use WireBug's decode sRTP tool for extracting and decrypting the RTP stream from the given file. I have to enter the key length and the encrypted key which I copied previously. The tool creates a new file with the decrypted stream. And if we now open this file and look at the RTP stream, we should see the decrypted call. This is an encrypted call. Great, it is decrypted. So now let's have a look at the provisioning. As an admin, you want as little effort as possible. Automatic provisioning and deployment of new phones, and after all, central administration. So let's see how this works in example of Unify OpenScape business. The server sends a HTTP request to the phone and asks for a so-called contact me request. The phone sends a HTTPS post request with information about itself to the provided IP address. The server now responds with a new contact me with the message, I have new configs for you. So the phone requests these new configurations, and finally the server sends back the configurations, for example, for setting a new call forwarding key. But if an attacker do this, the phone says, okay sir, you're the boss. And we have something like remote code execution with administrative rights. So it's time for the next demo. Here we can see the admin web interface of a VoIP phone. Now I try to log in. As expected, the authentication failed. And now I pretend to be the provisioning server and instruct the phone to set a new admin password. Yeah, I changed the field type to text so you can see the entered password. And yes, we are logged in as administrator and have the full control of the voice over IP phone. So now focus on the soft phones. Soft phones uses sRTP SDS2, but some newer soft phones also supporting ZRTP. ZRTP is similar to SSH, where we have a Diffie-Hellman key exchange between the media endpoints. The problem is, there is no information in the signaling part that the soft phones using ZRTP. That's because they are sending these ZRTP hello packets to each other. But what happens if an attacker could drop these hello messages? Let's have a look at the next demo. So I have these two soft phones, and because Alice is called Bob too often in the past, Bob is now calling Alice. And if Alice accepts the call, we can see this encryption symbol with the information of ZRTP. Okay, let's have a look at the network capture. And here we can see the ZRTP packets. And if we analyze the stream, we should see an encrypted RTP stream. Yes, there it is. Now I start WireBug's ZRTP downgrade tool and see what's happened. If we now have a call between Alice and Bob, we see no encryption symbol anymore. Okay, let's have a look at the network capture and Wireshark's RTP player. There we can see an unencrypted call. Therefore, the attack was successful. And the tool also responds a successful downgrade to clear RTP. Okay, now let's have a look at the Active Directory connection. As previously said, the administrator do not want to maintain 2 or more user databases. So that's why Active Directory replication is often done. So very simple, add a query to get user informations like their name and phone number and so on. So what do you do as an admin? You configure the systems as it is recommended by the manufacturer, right? But if we look at this example of a voice over IP manufacturer, we see we should enter the domain administrator account and query the Active Directory with an unencrypted LDAP. Bad idea, right? Therefore, if an attacker is able to man in the middle this, he takes over the domain administrative account. And by the way, in past projects, I often have become domain admin by exploiting exactly this situation. Okay, now it's time to attack the PBX. SIP proxies often have the problem that user enumeration is possible. This is done by sending a register request to the PBX. And if we receive a 401 or 407 response, we know the PBX wants authentication data. That's usually an indicator that this user exists. It's similar like in web application when the response says something like user exists but wrong password. Additionally, if we get a 200 OK response instead of 401 and 407, we are registered without authentication. Spoiler, yes, this happens in practice. And the next problem is online brute forcing. Here two problems come together. There is no technique like CAPTCHAs or something like that to slow down and limit the attack. We could only block the IP address or the user account itself for a specific time frame. But telephony should always work, right? Because it's a telephone and the telephone has to work, always. And the next problem is that zip extensions often have weak passwords like 12345 or 000 and so on. That's why online brute force attacks are often possible and in combined with user enumeration also successful. Okay, now let's see the demo. For enumeration, we can use WireBug's tool zipenum. It uses a zip request given by a file and replaces the variables inside. For users, you can use delivered user extension files or your own file with usernames. Now, I run the tool to enumerate users. And depending on how fast the zip stack of the zip proxy responds, the enumeration takes time. But finally, we are able to enumerate the existing zip extensions and also register to all zip extensions which do not require an authentication. To show the difference between zip stacks, I have a second IP PBX which we will enumerate. And there you can see it's much faster. Okay, let's see zip brute forcing. To brute force the zip extension now, we can use the zip brute tool. The requests are also based on the given file. And in default, the tool uses a password file with 1 to 6 digit numbers. For our online brute force attack, we want to use our own password file and brute force the password for the zip extension 87. And yes, we were able to guess the password, which is 9999. So we are done with the internal network. But we also want to call external parties. So let's have a look at zip trunking. For zip trunking, there are two modes available: the registration mode and the static mode. By the way, in the main RFC 3261 of zip, there is no talk of trunking. And yes, zip is originally not developed to have trunks. Okay, so in registration mode, the authentication is done by username and password. So it is similar to the internal PBX and soft phones, for example. The security in this mode depends on the password quality. In the static mode, the authentication is done by the source IP address. And the security is based on the network access control lists you have configured. Okay, so as said, in registration mode we have a similar authentication like internal when using zip phones and PBX. Therefore, we have the same issues, user enumeration and online brute forcing, right? The answer is, it depends. Often zip proxies of ITSP providers replace with 401 messages for any requested username, so you could not enumerate users. And yes, this is also the recommendation for your internal zip proxy. But what's about online brute force? Well, if we have no permission of the provider to pentest this, we cannot do this. But in practical, I am very bad in typing complex and long passwords into hidden password fields. Therefore, I need many attempts to type the correct password. And after all my registration attempts, like about 50 times, I am successfully registered. But seriously, there are some SIP trunking providers where online brute force attacks are possible. And because the username is usually the phone number, you can easily find the username on a company's homepage, for example. But if we use the static mode, the security depends on the network rules, because you have to make your SIP port external reachable. So if you miss to configure a whitelist of the SIP proxy IP addresses of your provider, you have the same issues as from internal. So you can enumerate users and brute force passwords. The next things we analyze are mobile soft phones. When we have external soft phones, we have external access to internal services. And usually customers say something like, "This is not a problem because everything is encrypted and we are using an expensive session border controller to detect and prevent attacks, and finally keep our internal network secure." For better understanding how the session border controller secures your internal network, I have a screenshot from a session border controller default configuration. Oh yeah, we have that very secure malicious signature database which protects our internal network from evil... Yeah, from evil what? User agents? Is this secure? Spoiler, it is not. This only protects you from low-level attackers like script kiddies who firing up a Kali Linux zip tool. Do you remember the advantage of WireBug to customize it? So that's what we could do. We can change everything in our zip request by simply editing the file or using our own request files. At this point, I would like to talk about a past project. I had this project where I have to pentest a session border controller and mobile SIP phones. Finally, I was able to eavesdrop calls, initiate and receive them, and they register internal soft phones. And all this from the public internet. Why? Because the expensive session border controller implementation only checked the user agent of SIP requests. Okay, but what's about the remote IP phones? Again, we have external access to internal services. External IP phones usually do the connection with a VPN or through a reverse proxy. For VPN, I often saw installed IPsec clients directly on the phone. For the connection through a reverse proxy, the phone optimally should authenticate with its exclusive client certificate. So the reverse proxy can verify requests and forward only authenticated requests to internal services. Again, let's look at an extract of a documentation of such a reverse proxy for external SIP phones. The reverse proxy will validate incoming registrations against their certificate. Alright, sounds good. The next sentence is, if the certificate is valid, the registration is forwarded to the PBX using TLS. Okay, go for it. But the next sentence in this documentation is the following. If the certificate is not valid or the incoming registration was sent with TCP, not TLS, or the checked certificate checkmark is not set, it is forwarded to the PBX using TCP. So, what's the actual security function of this reverse proxy? I don't know. The full documentation can be found here. So if you use this reverse proxy with the recommended configuration, we can attack internet services from the public internet. Okay, so what's left? The conferencing solution. At this point, I will not go too much into details of WebRTC, interactive connectivity establishment, and conferencing units. But important to know is that it was agreed to use sRTP DTLS in WebRTC. So this is another method to exchange the key for encryption. By using DTLS, the endpoints exchanging the AES key for encryption in the DTLS channel, which is like TLS for UDP. And to verify the identity of the other side, they're sending the fingerprint of their certificate in the signaling stream. So if the received fingerprint matches the one which is present in the DTLS channel, the connection may be secure. The advantage of this is that the conference server do not know the key for media encryption. It is not really end-to-end encrypted, but I think it is better than sRTP SDS, where everybody knows the exact key. Before we start the demo, there is much more to talk about conferencing and WebRTC, so if you want to know how it works and how secure this is, read my publication about conferencing analysis. It's available on our homepage. Okay, now it's time for the demo. For WebRTC analysis, we can use the built-in tools of modern browsers. For Chrome, it is WebRTC Internals. So now let's see what's happened if we receive a point-to-point call in Microsoft Teams. There it is. Then we have a new object, which stores the attributes and parameters of this session. And when we look in the remote description, we can see there is a fingerprint of the opposite certificate. So we can verify the identity. And also the same for the video stream. Similar to the remote description, we can find our own fingerprint of the certificate in our local description. And finally, we can see the audio transport that the audio stream is encrypted via AES. But what's going on in a conference in Microsoft Teams? So I have to set up a quick conference. And yes, I can join it. So now we're in the conference. And again, we check the session object. And yes, what's that? It is the crypto attribute for sRTP SDS. Yes, we also have that fingerprint in our description, but what's going on with the encryption? Which method will be used? And as we can see in the local description, there is also the crypto attribute. And no fingerprint here. In the audio transport, we also not see the cipher for sRTP. So the answer is, in this conference, the encryption is done with sRTP SDS, which means we are sending the key to Microsoft in clear and Microsoft server sends it to the RTP endpoint. Okay, let's have a closer look at that. I set up Burp Suite as an HTTP proxy so we can see the traffic. And again, we are joining the conference. There it is. Okay, now let's check the HTTP traffic. There we have the crypto attributes in a post request. Let's have a look where this key is going to. So the key is going to this external IP address of Microsoft. But if we check Wireshark, we can see the audio stream is going to another external IP address. Summarized, this means we are sending the clear IES key for RTP encryption to an external Microsoft server, and this server sends the key to another external Microsoft server, which is our RTP endpoint. So this is really not end-to-end encrypted. And do you remember a similar story about sending keys around the world this year? Zoom was in the headlines this year because of this problem. So we have this similar issue in Microsoft Teams, right? Just think about it. Now we come to the conclusion and recommendation. Voice over IP and unified communication means not just to have few IP phones in our network. Do not trust the encryption, which means manufacturer often developing in a just works principle. Think twice if you follow manufacturer documentations. Include voice over IP and unified communication components in your IT security concept. Do voice over IP and unified communication penetration tests. And as Joe McRae said in his talk at the Hacktivity 2012, smart people defend your networks. Products do not defend your networks. And just to get sure, the problems and security issues we attacked in this talk are not new vulnerabilities itself. This is just the result of insecure configurations and implementations. And finally, my daily work as a penetration tester. So, thank you everybody for your attention, and if you're interested in more or just want to talk about voice over IP and unified communication security, you can contact me here.